Hi, and welcome to the third part of our SPSS ongoing tips and tricks series. And we're turning our attention now to visual binning, which is a really powerful, really useful procedure that many people have discovered within SPSS. It's used for when people have scale or numeric fields and they wish to create banded or grouped fields. And if you're not sure where you find it, it's actually under the transform menu about halfway down. Visual binning. Let's have a look at what we can do with it. Okay, so we've opened up version 24 of SPSS statistics, and I've loaded in employeedata.sav. This is a sample file that ships with SPSS. You'll find it in the samples folder where SPSS is installed on your own machine. And it's a good data file to use. It's fairly easy to understand. Each row represents a different employee within a bank, and we've got a bunch of different pieces of information that we've recorded about them, including their job category, the length of time they've been employed, whether or not they're male or female, and also some stuff related to their salary. So this is a good one to use to illustrate the problem of banding or grouping continuous fields into sensible groups, into bands or groups that make sense to us. And if we actually wanted to summarize or explore this particular field, I guess we could start and just right click on it and hit descriptive statistics. Here's a field here called salary, and you can see that this is a continuous field. It ranges from $15,000, that's the minimum salary, to $135,000, and we've got a reasonable standard deviation here, $17,000 about the mean. The difficulty is that if we wanted to slice this into groups, where would we do that? And where would we cut it? Would we start from the minimum salary up to $25,000 or $30,000? Would we try to get even numbers of cases in each group? Would we need to take into consideration missing values or unusual values or extremes? These are all questions we'd need to think about. And perhaps before we started the process of deciding where we were going to create our bands, we might do something like a little chart. And normally when one tries to represent information like this, it's continuous in nature, we would do something like a histogram, which gives us a sort of idea of the shape of the distribution. Okay, so here's a histogram, and we can see that this is as is typical of salary distributions, very skewed distribution, where the majority of the employees are around about this 25,000 mark here, and we've got some people above $75,000. So slicing it into even chunks may not necessarily be that straightforward without further investigation. And this is where visual binning becomes really powerful and really useful, because to visually bin this particular field, all we need to do is go to transform, call up the visual binning procedure, which will generate the dialog. It asks you which field you want to look at. You could actually bin more than one field at any one time, so it's really useful. And what it does is it starts to scan the data. Now if you've got like 10 million cases, you can tell it to limit the number of cases to scan data, because it doesn't necessarily need to see every single value in order to do this. But even with 1 million cases, it'll do it fairly quickly. If I hit continue here, this is a very small data set of only a few hundred cases. And you can see instantly what it does is it gives us a histogram anyway, so that's really good. And it offers the opportunity for us to create a new field, so we could call this sal band. Just give it a field name. And if we don't like the label that's suggesting here, which is current salary binned, we could call it banded, or we could say grouped or something like that. Change that. It tells us what the minimum and maximum is, and then it offers us the opportunity, to punch in numbers. It's even given us a little report here on the number of cases that it's scanned. Where will we slice this distribution though? Well, this is where it starts to get really interesting. If we click on make cut points, we can tell it, where to begin the first cut point. We can say start at $10,000 and, $10,000 and, have 3 cut points with a width of X. That wouldn't really make a lot of sense. One of the procedures I tend to use is this middle one, where it says equal percentiles based on scanned cases. That means trying to create groups with roughly the same number of cases in them. So I could say, rather like slicing a cake, I want you to create 3 cut points, which is a width of 25%. So you're getting 3 cut points, that will create 4 groups. And if I hit apply at that point, it will do that. Notice that we can also slice the distribution based upon the mean and the standard deviations, and so on and so on. So if I stick with this option, click apply, it shows us exactly where those points are. Now again, we can see here that it's actually slicing the distribution. We have the little bars appearing here to slice the cut points. $24,000, $28,000 respectively, and $37,000 and $50 respectively. Now if I took that last one there and just moved it up out, you'd actually see it updates it. It's really clever. So we can play around with this and just visually bin it, and it will just update it. So that was $37,000 and $50. So I can just round that down to 37,000 if I don't like the $50 on the end, and it will just, of course, readjust that point. Again, here with $28,875, I might round that up to $29,000. I'm not going to get exactly 25% of cases falling into each group as I start to mess about with these cut points, but they may be more meaningful to my audience, to the people who are actually accepting the analysis that I'm producing. Now if I go and create this field, what it will do is it will create a field where it says 1, 2, 3 and 4. There will be no label attached. There will be no value labels for each of these groups, so I can actually get it to make labels, and it makes labels for me. So if I don't like 37,000 and 1 cent, or if you like plus, or $1 plus, then I can just call that, I can round that down to $37,000 and say over $37,000 if I don't like that. And if I don't like the less than or equal to, I can say less than or equal to, type that in. So I can edit these value labels as well, and you can even reverse the scale. It's really easy to do it because it's doing all the work for you with regard to finding the best places to slice the data. If I click OK at that point, it tells me it's going to create one field and one new variable it's created, and it jumps to the output window because in the log here it's telling me that it's actually run this particular recode procedure for me. If I go back to the data by clicking on the red star, here is my field that's been produced, my salary field which has been banded or binned. I right click on it and ask it for descriptive statistics. Here it is. It's roughly 25%. So here are the value labels appearing, and of course I can now use this field in things like crosstabs. So I go to descriptive statistics here and call it the crosstabs procedure. I can put banded salary into the rows and gender across the top and say, okay, show me the percentage of males and females in each of these different groups, and that's about bar chart, something which I couldn't really do as a continuous field. So that's how we use visual binning, and that's why it's so powerful and so useful.